All set?
Almost. Preparing to live stream the webinar, setting up your webinar for YouTube. Yep, looks like we are set.
Great. So you mentioned you were going to try to look over some of this earlier. Did you have a chance or?
No, I was yesterday looking up other things, so. Yeah.
Not a problem. So yeah, I've got us down here. So the main thing we're introducing in this PR is a new compat utility that's based on the MDN data, browser compat data. So what we had before was an is supported method that was backed by caniuse, where we had to understand the actual feature name structure in order to be able to do the query. And what we're introducing now with feature query are a series of kind of more code related queries that you can do. So for example, with an element query here, if I hover this, can you see the hover?
Yes, I can see the hover.
Okay. So you can pass in just the name of the element. If you're doing an attribute query, it could be attribute a potential an optional context element, an optional value if you want to validate the value as well. Mm-hmm. I'm actually going to move my window here for a second. Is the text big enough on this, by the way?
Yeah, I can see it. Okay. Well, I have a bigger screen, but.
Okay. So yeah, we kind of have an is supported API that we use to update those existing hints. And then in preparation for migrating hint compat API over to use the same utility, we've got the get unsupported call, which takes that same query. The only difference is one returns a Boolean and the other returns an array of unsupported browsers based on the ones you passed in. And those browsers are expected to be in the browsers list format, but like what you would get back from browsers list, not what you would pass in. So it'd be kind of the same as what we currently have attached to the hint context. Mm-hmm. And so yeah, there's a few example queries I stuck up here. I should probably still update this comment with a more general description as well. But kind of gives you a basic idea of the various different ways you can use this for HTML and CSS, which are the two categories we support at the moment.
Cool.
And so yeah, is supported is just a thin wrapper around get unsupported. Get unsupported will return null if all browsers were supported, so we can just not that. And otherwise, we're going to break it down based on the query type. We use some type narrowing here to get to the actual expected query type. And there's actually kind of a cool feature in here with TypeScript with exhaustive check. We can actually ensure that we've handled every possible value in the union for feature query by trying to assign it to never. So for example, if I cut off one of these.
Nice.
So we can see that we haven't handled selector query yet.
That got added like recently, right?
Recently, not like super. I don't remember exactly how long ago, but
super cool.
But yeah, kind of a neat trick to get compile time checking on handling all those cases. So. But yeah, otherwise this particular file is not too interesting. So let's do the markup ones first. I've got them split into kind of HTML and CSS. So of course, both the attribute and the element are going to be implemented in the same file. With a few different helpers, and down at the low level, this is going to be processing the actual support statements from MDN. At the higher level here, we're caching the results because there's a fair amount of searching that goes on, potentially multiple lookups to resolve one of these. So knowing that just like what we have with hint compat API today, when we're actually iterating over the source code for something, there's a really good chance we're going to have repeat queries. And so we just set up a small little cache. It's backed by a nested map to make these fast. It takes the key that we've constructed kind of per type of query, and then the actual browser's list is also used as part of the nested key for the map. We can peek into that a second here. So yeah, it's just a map of that original string and then mapping our list of browsers, and then the actual value we get back, which is either our list of unsupported browsers or null if there weren't any. And so a couple helper methods to deal with checking, getting, and setting. And for the most part, this is just a generic thing. So we pass in the thing to actually get the value. If we find something in the cache, we'll use it. Otherwise, we'll get the value and add it to the cache. Does that make sense?
Yes, give me a second.
I kind of went over that a little quick, so I'll give you a second.
Okay. Okay, yeah. Okay.
Yeah, so if I'm going to jump back here. So yeah, you're going to see this pattern basically on each of these different types where we're just wrapping with get cache value, the key that's specific to the type of query we're doing. And then we pass in the actual getter that we can use in our context. So if there wasn't a cache value available, this will run and do the actual lookup for us. So elements, one of the simplest ones, which makes it nice to look at. We've just got the structure MDN HTML elements. Now here we're actually referencing something that's our built version of the MDN data versus what we did before was actually reference the full set. And then when we did our bundling with Webpack, we trimmed it down to save size. Now we're actually doing this as part of the utility. I mean, at this level, you're not going to notice a difference, but except where we import from. So we actually are importing from our local browser compat data, which is sitting here ignored because we generate that from this pretty much the same script we used to do as part of our Webpack step. It's just now been moved here to the util.
Okay.
Otherwise, we still use this. Oh, go ahead.
Yeah, and the reason that you are using that one was to get typing and some other things.
Well, part of the advantage of putting it in here instead of a JSON is it'll actually go through the minification process. So I don't have to make it quite as compact as I did before. I can keep it a little more readable. So if you drop in here, I can keep all the white space and stuff knowing that it's going to get stripped out later. And it'll do a couple other optimizations, drop all those unnecessary quotes. Where when it was just a JSON, it just got put in using a raw string into the bundle.
Okay.
Typing wise, we're using the same types we were using before. Except at the very top level, I did change the top level type to scope to just the things we currently support. So knowing that we only we don't expose anything around DOM APIs or JavaScript yet as part of our bundle, the typings do catch that for you, which is something we didn't have before.
Right.
Other than that, it's just generic identifiers, which are they're imported directly from the normal NPN package for the browser compat data. Okay, so let's get back to element here. So we've got the element name, the structure of the data, is basically that actual element name we can look up. So we'll actually go down into get support unsupported browsers. For the data, anything that's actually interesting is stored on a _compat object. So if we don't find the feature, or if it doesn't actually have compat data available for it, then we're just going to return null because we don't know anything about that particular feature. It's the same as what we're doing for compat data before. If we don't know, we assume support.
Okay.
Otherwise, we get the support object and we prepare to build up our unsupported list. We iterate through all the browsers that were provided. We map the names from browsers lists to the names that the MDN data uses. Get the support object for just that browser. And if there is one, then we check to see if it's unsupported, and if so, add it to the list. If that particular browser didn't have any data for that feature, we also assume support. Same way, unless we explicitly know it doesn't have support, we always assume it's supported.
All right.
That helps us not generate a bunch of noise when there are gaps in the data. So is browser unsupported? So the actual support statements themselves can be relatively complex. I actually have an example handy here. So let me pull up the tests. So here's an example of what one of these might look like. So you have compat, you have support. There could be any number of browsers here. In this test case I put together, we just have one for Opera. This is actually from keyframes. So these are listed from most recent to oldest. And so you may have only one entry, you could have multiple. This one's fairly complex in that if you start at the bottom up, it was originally added with a -o prefix. And then the unprefixed version was added, but then when they cut over to Chromium, the unprefixed version was removed. And then they gained a WebKit prefixed version, and then didn't become unprefixed again until version 30. So,
yep, not bad.
So there's so this test case is just covering kind of the before, during, and after of each of those cases to kind of prove that we can handle the subtle nuances of the data. All right, so if I get back here. So yeah, so kind of as you've seen the structure, now it will make kind of sense as we look at browser unsupported, we're actually going to do a loop through each of those simple support statements. Now, it may not be an array. If it isn't, we're just going to wrap it in one to simplify handling. And we kind of treat this as first clear rule wins. Once one of them comes back as yes, then it's not unsupported. It is supported. If it does come back as no, because a feature could have been temporarily removed, as in the example that I showed you, we set the status to no, but we keep looking because there could be another yes case further back in the history, depending on the specific version we're looking at. And otherwise, if it's unknown, we don't do anything. So either we hit a yes, or we're going to get through all of them, and we could still be sitting on unknown, or we could be sitting on no. If we're sitting on no, we finally know it's unsupported. If it's unknown, then we're going to, as I mentioned earlier, assume support. Looking at an individual case, there's a number of different pieces. Particular support could be behind a flag where the user has to enable it. So we don't pay attention to those. If it's prefixed, we did actually pass a prefix down here that we were looking at. This is a little bit interesting because prefixed properties can be stored in two different ways in the MDN data. Sometimes if the property was only supported in a particular browser with that prefix, it'll actually be listed just with the prefix in the list of properties. But if it was a standardized property that multiple browsers supported, then it'll be under the standardized name with a prefix entry on the support statement telling you what the prefix is. So when we get to like CSS, or we're looking at attributes that have prefixes, we'll extract that prefix out. We'll first try to look it up with the prefix, And then if we don't find a version there, we'll look up without the prefix and pass what the prefix was down. So when we get here, the prefixes have to match. Either the feature was listed without a prefix or with the same prefix as the support statement. If they don't match, then it doesn't tell us about that particular feature. This is actually the subject of one of the active issues on MDN, is changing version added true to actually indicate at least the first version that was tested in. So we will have to do an update here once that schema change goes through. Right now, this basically means some version of the browser has support. We don't know which one. And so we assume yes.
Okay, do you want to add a comment in here pointing to the MDN issue?
Yeah. We don't like
yeah, we don't like
to do
to update the rules of comments, I think.
So yeah, that's kind of the way that that'll look. Okay, otherwise it may have never been added, so we know it's not supported by that statement. It could have been removed before the current version we're trying to test, in which case it's not supported. And then if it was added by our target version, and we're just using semver to do the comparison. We have to coerce it because semver expects it to already be in the 3-segment syntax. So the actual data, we might just have the number 10. So coerce here will get us into the proper format so that we can do the comparison. And if there's any other case we didn't cover here, like if a feature was removed, but we don't know when it was removed, then we just assume we don't know support. So yeah, this is kind of the most detailed innards of how this works, but it's very important for the rest of it to come out right. Any other questions while we're here?
No, trying to get everything in.
Yeah, you may want to read this one a couple times.
Yeah, no, I'll reread everything, but it's good to have a quick overview or an overview before.
Yeah, and especially for this one, I think having the complex test case helps because there's a lot of ways that these can fit together. We may even want to think of a couple more test cases to add there.
Yeah.
Although the one I included covers the most complicated one I've seen. So.
Yeah, it's like adding one prefix, removing, actually adding another one, removing it.
All right, so back to HTML here. Well, actually, we'll jump back here. So yeah, we covered, once we get an answer out of that one, we're back up here, and that basically just controls if the browser was unsupported, we add it to the list. When we exit out of here, if there was nothing in the list, we'll return null. If there was something, then we just return the list of unsupported browsers, which will be a subset of, or the full list that you originally passed in. Okay, so element was pretty simple. Attributes a little more complicated. Just so if we ever actually are debugging with these keys, rather than seeing the word undefined pop up in here, I had them fall back to the empty string if they were left out. Would have worked fine without that, and just thought it'd be a little more readable for debugging. All right, so with an attribute, the attribute might be described in the context of an element, or it might be a global attribute. So if we have an element to look at, we'll actually try to get the feature data for that element first. And this helper, actually, interesting, this helper should also be used down here now that I'm looking at it. note for that. And this is because of handling the prefix versus unprefixed behavior that I was talking about earlier.
Yes.
So what we're passing in is the context to search in. So we're looking in the elements collection in the data, and then the actual name of the element we want to look up. So on that context, we may have the name of the element directly. And if just to handle the fact where the context didn't exist at all, we also just fall through here. We're just doing a multiple return of the actual identifier that was in that place of context, and then a potential prefix that was associated with it. So if it exists directly, we didn't use a prefix. So it was either listed at the top level with a prefix, or we were past the unprefixed version. Then we just use some of the post CSS helpers to get a prefix and what the unprefixed name is if we didn't find it, and we'll try to look it up again unprefixed. So basically it's just a double lookup, one with the original name and one trying a potentially unprefixed name.
Okay.
And since we have to do that frequently, that's why it's a helper.
We do this for attributes.
So this one was getting us the element, because if it's an attribute defined on an element, this is where it's fun. So let's pick an attribute like integrity, right? So in our built version of the data here, so link supports integrity. So if it's scoped to an element, it's going to be listed underneath that element name. So we need to look this up first, and then we can use that as our context to look for the attribute. And if it's not specific to a single element, it could apply to all elements, then it'll be under the global attributes section. Okay, back to HTML here. So really, we're just trying to find an element context first. So then we'll try to look up that attribute under the element. And then we'll have the data and prefix here. We don't really care what the prefix was for the element case, because we won't be looking for support for that element in this query. We're looking for support of the attribute. The intent is if you want to understand support for both the element and the attribute, you run two queries to is supported. One for just the element and then one for the attribute. Here, the element is just a qualifier to help you identify which attribute you're talking about. Does that make sense?
Yeah.
Okay. So we get the actual compat data out, the identifier for that attribute, and the potential prefix that was split off of the name we originally passed in. If we didn't find anything, then we'll go and do the same search on global attributes, which I showed you earlier. And if we're actually testing a value instead of the attribute itself, then we'll use the attributes data as context, and we'll search for the value. And then that basically sets us up to have the actual support data we're looking for, the prefix. So like here, values, I'm trying to think of a good example off the top of my head of one of the prefix values we'd be dealing with here. There aren't that many in the HTML space. There's a lot more in CSS, but ultimately goes through to the get unsupported browsers query. Any other questions for this file?
Nope.
Cool. We'll keep taking it a little bit deeper. We'll go over to CSS now.
Okay.
Okay, so here we bring in a little bit more support than what we currently have in Hint Compat API. So once we migrate that over, we'll get the benefit of these features. We can actually tokenize values of properties and break down and tokenize selectors using the associated post CSS modules. And so we'll use those down later. So if we kind of go from bottom up here.
Okay. For the require, we will be able to remove it, or do we have to? We'll have to put it in the.
The require?
Yeah, instead of require using the import for when we start doing tree shaking.
Yeah, I don't know if that's actually going to be a blocker for doing the tree shaking or not. But the way these modules are currently defined, we do have to import them through require because they export functions.
Okay.
So we'd either have to, if it is a blocker, then we'd have to probably try to submit PRs to update those dependencies or find a different dependency that exports something in ESM.
Okay. Yeah, I think that, yeah, or maybe we'll wait until Node 14.
Yeah.
That's a way ago. Okay. Yeah.
Yeah.
For that.
I'm not sure at the moment. Still have to look up a little bit more on how that's going to work.
Yeah, I mean, definitely not a blocker right now.
Okay, I don't want to walk through each and every one of these in detail because now it's going to start feeling a bit more competitive or repetitive. But I will summarize that for the selectors, we're just looking at pseudo selectors at the moment. They're probably the more interesting ones. We could end up caring about some of the attribute and combinator selectors. Those are going to need a little bit more special handling because they tend to be characters and they're not stored in the data that way. Most of them are supported across all the browsers we care about. So at the moment, the biggest area of interest is the pseudo selectors, and that's where you get the pseudo elements as well for styling form controls, scroll bars, stuff like that.
Yep.
And so we're just walking those and stripping off. They're actually stored, or they're returned with the leading colon or double colon from the selector you pass in. They're stored without that in the data, so we strip it off and then actually go look off of the selectors collection with the name and then look up and get unsupported browsers. So yeah, if we come in for like an @ rule, it's a similar thing, no extra processing needed here. And then a declaration is where we have the property or the value. So we're going to look up on the properties first. And then if you had provided a value, there's a special handler here for get value unsupported. And this is because we're not just looking up exact string matches in the value case. It gets a bit more complicated. Now, some of them are going to be exact string matches, so we will try that first. If we get an exact string match, great. We'll use that and check the browser support. Otherwise, we're going to try to match a partial value.
We have a test for this too.
For these, yeah. So for the other tests, what I've done at the moment is I didn't unit test them as much as I did a higher level integration test. Although it's still a lot lower level than hint compat API tests, which spin up a web server. But we're just doing it all through is supported and get unsupported, the public APIs that are exposed out of here. And so we have conditions that test each of the types of queries. So element query, attribute query, an attribute value query, property, whether it's prefixed. And then when we get to the property values, we've got full match, prefix full match. So there's keywords of the tokenized version. There's a regular expression match for tokens as well for things like the alpha hex values. So we have kind of concrete examples of each of those that I tested at this level. So we do cover them. Code coverage wise, it should all be covered. Hard to confirm at the moment since we have that other bug, but.
Oh yeah, I forgot.
Does that make sense?
Yes.
And these will run a lot faster. Actually, once we cut hint compat API over to using this, I want to trim back what it covers in its test cases to be a lot more focused on just the tokenization and walking of the source code and not validating all the edge cases of the MDN data. We'll do that here instead.
Mm-hmm. Yeah.
And that'll help improve or reduce our time spent running tests. Because we don't need to spin up all of webhint or a web server to run these tests.
Yeah, and especially because there are so many edge cases and different configurations. So it's like also different browser instances and everything. So.
Yep. Okay, so jumping back into get partial value unsupported, basically what happens is we have a whole bunch of entries sitting under the property. This is a good one maybe to jump over and look at the data again, actually, before we go into the code. So let's do color, right? Because color has alpha hexadecimal notation. So obviously nothing's going to get passed to us that allows us to match this particular key. So we've got to iterate them all. And we'll look for having this matches. And we can use that matches to go through each of our tokenized pieces and test to see if it matches the pattern that represents this feature. So if we see that in code here, so we loop through them. The match could be a full regular expression against the full value. But if it's keywords or if it's a token regular expression, then we've got to loop through the tokens we got from the value parser that we took up here. And so then for each of those tokens, we'll either check to see if it's in the set of keywords. Keywords are used in, like the example we have of keywords so far is 3D transforms. So I think, oops, 3D. There we go. So yeah, we're here in transform. There's a 3D entry and there's a list of keywords that you'd potentially see that represent that, hey, this is actually a 3D transform. You know, a lot of the MDN data isn't using this yet since the schema was only recently updated to add support for matches. This is an opportunity where we could contribute more back. I know there's a list that's being maintained. It could be some good PRs for us to do to find a few more places where this would be useful and submit those. So yeah, so the regex token was the alpha hex example, and then the 3D transforms is keywords. Looping through each of those and then going back down to our lowest level helper of get unsupported browsers. And it's just kind of a series of checks and fallbacks as we get through each of these cases. But the other big difference you'll notice here with how this is structured versus what we had with hint compat API is each of these, none of these functions are reliant on any state. They're all receiving all the data they need to do their processing and returning a consistent result. So they're all pure. The same input is going to result in the same output every time. And you don't have to jump through overrides as much to figure out which one's being invoked.
Yep.
Okay, so, and then, oh yeah. Tokens, there's a lot of different tokens potentially present in a value. For the purposes of matching, we only tend to care about the names of functions like RGBA or ones that were identified as words. The other token types are like strings that would have been, user data, things that we don't actually need to match against. So that's why there's this helper here to just walk and strip out the ones we actually care about. Okay, I think that hits all the details of the implementation. At the top level, we're just exporting, as I mentioned before, those 2 helper methods. Everything else here is internal. So it's just used for the implementation. Anything else you got a question on so far?
Nope.
Did you want to?
I mean, I can see how this is taking longer than expected.
Yeah, good. Yeah. Well, and the main thing I wanted to make sure we had here, if we just wanted, oh yeah, so that's covering how this is implemented. We need to, now we'll jump over to actually some of the updates we already did. Mm-hmm. But the important thing I wanted to make sure we had here is that this could support everything hint compat API needed, mm-hmm. even though we're not cutting it over in this PR. Mm-hmm. All right, so I think this is where it's going to be a little bit easier to go to the pull request view to see the other stuff we touched. So some of the updates you're going to see here is we did an overall bundle and reduction in bundle size. Nice. It was the additions that came from one of the other PRs that was merged in for the analytics library. Mm-hmm. I think we're at about 635 right now. Mm-hmm. So I just rounded it, or 636. I just rounded up, set it up at 640 for now. Mm-hmm. The browser extension no longer references the compat data library. It's just pulling it from utils. And similarly, it no longer has a pre-build step for bundling the library because we've now done all of that in utils. The webpack config, we don't have to substitute in our bundled, our packed version. Here, let me give us a little more room here.
Yep. Yeah, I know what.
But yeah, you get the gist of it. So we had an alias to substitute in our packaged version for the actual import of the NPM module for MDN browser compat data. Since we're now directly referencing our utils, we don't need that. Mm-hmm. And so dependencies for hint compat API are similar. So while hint compat API, none of the callers have been updated to use the new utilities, it is using the new bundled data.
Okay.
So it doesn't have a dependency directly on the browser compat data either. It's now indirect through the utils. And there's a couple import updates just to make that real. Mm-hmm. And we're using the long disk path just because we're going into this is for the browser extension. So at the moment, we still need to sub-reference the module. Mm-hmm. So yeah, that's another update related to that. Mm-hmm. And then in the tests, since this brings us over to our package data instead of using the full data set, as we talked about before, some of the tests that were previously written tested very old browser versions that we didn't care to include in our data set. Mm-hmm. And for the time being, I've updated to skip those tests with a to-do to try to find an equivalent newer feature that covers the same case. I have not done that for each of these yet. I think we've got about, if I remember right, 9 to 12 of these. Okay. Out of the 100 or so that were written. But yeah, you can see here. Oh, what's another good example? But yeah, I probably only really care about looking at half of this one at a time anyway. Mm-hmm. Yeah, older versions of Chrome. If any of them were easy enough to just update because the data had changed. So like I did the updates here, I think it's in CSS actually for what was blocking version 0.76 from merging in. And that's sitting of the MDN data. Yep. And that was because box lines actually gained support or knowledge that Edge explicitly didn't support it. Mm-hmm. Which changed the output of our message because it was now all of the target browsers that have been passed in. So we just had to update the matching message.
I wonder when the MDN data is going to get updated with the canary and def channels of it?
Yeah, I don't know. That's actually a good question for we should ask.
Yeah.
I don't know what the thinking's going on there. I assume it will probably go something. Well, they don't tend to pick up beta versions too often, I guess, is part of it. Like most of what's documented isn't beta.
No.
It's
Okay, so there are still. Makes sense. Yeah, and we should look also into browsers list also once we are ready to go mainstream.
Okay, I'm kind of going to skip over the other ones here. There's some small changes. Like I said, the categories are kind of the same. Now we're getting into the hints that we used to use the caniuse API for. So disown opener was one of them. Let's close this on the side and actually switch the diff view. Nope. Not that I'm seeing. Okay, we'll just carry on. All right, so switch the import. We don't need the to-do because this is what the to-do was there for. In this case, due to the structure of the data, we actually have to look it up on rel up on link, even though it should be A. That's something that I've got an issue logged on us to follow up on in our GitHub, and probably open something to make a proposal to the MDN data. But we can still figure out whether there is support. It's just the query is not quite right. Let's see. Then we also had manifest as valid. These are going to look similar. The other thing we have potential here, and I left it to do for this, is we cut over. There's a number of the other checks for like specific keywords and stuff that are also represented in the MDN data. We potentially could do a lot less in this particular hint and offload more to just the is supported check.
Like, can you repeat that part?
Oh, because there's additional checks for specific color values that, but I think we always use the example Rebecca purple, but trying to refresh my memory here. But when I was looking at this earlier, I think there's an opportunity for some of these that are separate checks to actually just be separate queries to is supported.
Okay, I see what you mean.
And I left it to do for that, for the color syntax checks.
Okay.
I wasn't going to try to rewrite the logic of that hint at the moment.
No, so maybe like try to get what pattern is being used in the manifest and see if all the browsers that you care support it.
Yeah, well, and the theory there is that basically, because right now I should go back to that one.
Okay.
Or no, I am still in there. When we're testing the colors, we're running a regular expression to decide if it's looks like it's a hex with alpha regular expression. What we could do instead is we could just take the actual value that was listed in the manifest and ask if that value is supported.
Yep.
Because of things like matches. Now that also means that we'll have to ensure that the data set we're using covers everything we care about. So it may still require updating MDN a little bit, but. Okay. Hint runner update was just to give me the option to skip those few tests so we didn't have to fully comment them out. It gives us the reminder that we are skipping them and needs to update per your suggestion.
I thought that we had this feature, but we don't have it.
Well, Ava does, but those tests were all coming through our.
Yeah, I was thinking of the ignore connectors because I remember that we were. I mean, when we are running the test, I see that I see that there are some tests that are already skipped, but those are the tests that we are skipping for some connectors, which is a different property.
Yeah, and that's passed at the configs level, which applies to all tests that were passed. We want to customize something per test.
Yep, totally. Yeah.
So I just plumbed a small little new feature to enable it.
Perfect.
And updated the hint test type to allow it. I did not extend it to hint local test. I didn't need it. I didn't figure I should add it at the moment.
Yeah, if we need it, we will add it.
README basically replaces caniuse with the compat section. These I also already exported flattened, by the way.
Nice. Yeah, that's another one that we need to get done sooner rather than later.
So for the utils, we bring in Semver, which we already used elsewhere in the project, so it doesn't add anything new to the bundle. What's new are the selector and value parsers. And then our dependency on the browser compat data moves here, but we've now upgraded to 0.76. This was moved. This is the script for generating our trimmed version of the data. And I had a couple fixes along the way for cases as I did go through and debug some of those test cases. There were pieces of data I found that were being stripped out that we needed. And so I added a few conditions to make sure those got included. And similarly, flagged support was an interesting one, because if we don't have any data whatsoever, we assume support. But we don't count something that's hidden behind a flag as supported. So normally I can delete it, but if it was the only entry for a browser, then I need to convert that to at least tell us that, okay, that means there's no support, because if I delete it, we'll assume the feature is supported.
Okay.
And then this was just setting up that little bit of typing in the export. Then you hit a bunch of deletions of can I use stuff, a little git ignore for that generated TS file. Browsers TS. And then we're in the new util code that we already walked through.
Yep.
So that is everything.
Oh, not bad.
All right.
Cool. Yeah.
Stop sharing my screen there, but yeah, it turned into a bit more than I was expecting, as you can see.
Yeah, I can see that. Yeah, I think that there is only the comment for the link for the MDN, then the other thing about that you wanted to use or that you forgot to use one of your helpers. Well,
yeah, I made a couple of those. I made edits while we were there, so I see them in my diff here.
Okay, perfect. Yeah, and other than that, let me know. Ping me when you push them, and I'll do another review.
Okay.
Offline with me, and then we can get it merged.
Did it feel like you were able to follow along with it? I mean, part of the goal here was to produce something that was a little easier for us to maintain than what we had before. So.
Yeah. No, definitely. I think it's a huge improvement to what we had before, especially because now a lot of the how do you say, the browser support infrastructure is shared across all the hints, and not like in one place we're using caniuse, in another place we're using something else. So this is great.
Okay.
So yeah, I think it's a lot of code to get on one down. So, but it's cool that we did this review and that this is getting recorded, so in case we need to go back, at least there is some history.
Yeah, and that's why I think it's good that we split this, so we'll actually update hint compat API later, because the PR had already gotten big enough that adding that on top of this, I think, would have just been too much.
Yeah, no, definitely. Like, we need to do a better job at keeping the PRs smaller. So
cool.
Okay.
All right.
Yeah, this looks awesome. So yeah, thank you.
Later.
Bye.